We have our last section before Thanksgiving break. Now, who remembers what we talked about during our last section before the exam? Indifference curves, all right. So what's an indifference curve? What does an indifference curve measure?
All the combinations of two goods that give you the same happiness that you're different to.
Exactly. It measures, yeah, exactly that. There's a great definition. All the points, all the different combinations of two goods where you're going to have the same amount of happiness. Let me mic off. Okay, starting here. Shorten my board space even more. Okay, so we talked about indifference curves. We talked about the marginal rate of substitution, which is the rate at which you would trade off one good for another and still have the same amount of utility. And then, and now we're going to talk about how that ties in with, we're going to bring this idea of budget lines, and then we're going to show that with a combination of a budget line and a consumer optimum, you can actually, give it away. The combination of the budget line and the indifference curve, you can get the consumer's optimum. Like that's kind of the goal of our course here. Okay, so first of all, let's talk about. Let's just draw a graph up again. We're going to stick with our movie tickets and our pizza slices. Let's have this here for reference. So remember we said that, we talked about our difference curves. We had a couple different points. We had A, B, C, D, how we want to say it. And then we said if A and B gives the same amount of happiness, they're going to lie on the same indifference curve. And remember that we talked about the shape of the indifference curve and how they were going to be bowed inward like this. They're never going to cross. They're not going to be upward sloping. They're always going to be downward sloping. And being on a higher indifference curve means you have a higher level of utility. So D is better than A and B. A and B are equal, and C is not as good as A and B. So now, why might we not choose D? D's awesome. We got lots of utility from that.
Budget.
Budget. What if we can't afford D? Okay. So we're going to talk about the terrible reality of limitations. We can't have everything we want. Okay, but first, let's talk a little bit about the slope and the fact that this is the marginal rate of substitution, and kind of go in a little bit more deeper as to what that means. So remember we said that the marginal rate of substitution of pizza for movie tickets is equal to the change, so the negative of the change in pizza slices over the change in movie tickets. So when we move from one point to another, we can measure, like let's add in another point, E. So the marginal rate of substitution from A to E, let's say that we lose 2 pizza slices and we gain 1, I don't know, so we go 3 to 4, and we go 3, 4 to 6. So we lose 2 pizza slices, we have -2. So first we start off with a negative before everything. -2, we gain 1, we take it. So we end up with a marginal rate of substitution of 2. So when we are, when we're at a point that's really high, like let's say even beyond A, let's say that we're way up here at point, I don't know, it's running back at this point. If we're way up here, what can we say about the indifference curve? It's very steep, right? Very steep. So what does that tell you about the marginal rate of substitution? The marginal rate of substitution is really high. So let's say when the marginal rate of substitution of y over x is high, of all, we note our indifference curve is really steep. And so what else? So that makes sense, right? So if we think about it in terms of this definition, and our indifference curve is going to be steep, we're going to trade a lot of pizza slices for just one more movie ticket. And that makes sense, right? Why would we want, when we're way over here, why are we willing to trade off a lot of pizza slices for just a small amount of movie tickets?
Diminishing marginal utility.
Right, we have diminishing marginal utility. So if we already have a whole lot, let's say we have like 10 pizza slices at this point, and only one movie ticket, then 10 pizza slices is a little much. Like we like pizza and all, but like, at that point you're kind of pizzaed out, and you really maybe like to bring a friend along to the movie or something. So your basically your marginal utility. Remember, if our marginal utility is diminishing, and you have a lot of something, the marginal utility of one more of that item is very low. And if you only have very little of another good, the marginal utility of that item is relatively high. So we can say, if we look at this in terms of the marginal utility, let's see, so the marginal utility of good Y, in this case pizza, is low. The marginal utility of good X, movie tickets, is high. So we can look at the marginal rate of substitution as a ratio of these marginal utilities. So we can say the marginal rate of substitution, Y for X, is equal to the marginal utility of X over the marginal utility of, sorry, this isn't X, this is Y. Now, I realize the video cannot see that at all. Let's try it again. Marginal rate, this is an important concept. Marginal rate of substitution of Y for X is equal to the marginal utility of X over the marginal utility of Y. And this will hold true at the consumer's optimum. Let's see, so this is, oh, I'm sorry, this is, I got it ahead of myself. This is always true. So the marginal rate of substitution along this is the ratio of the marginal utilities. So you can always think back, is the marginal utility high or is it low? You think, well, I've got a lot of pizza. Clearly, my marginal utility for pizza at that point is pretty low. And my marginal utility for movie tickets is pretty high. Well, my marginal rate of substitution is the marginal utility of the X good over the marginal utility of the Y good. So we must have a very high marginal rate of substitution at that point. You can also just think, well, hey, if I have a lot of pizza, not a lot of movie tickets, I would trade a lot of pizza for a few movie tickets. Same thing on if you're down at B or even further out, same concept, except it's going to be the opposite. So if we're way over here at G, so to say, what's our marginal utility going to be like? High or low?
For movie tickets?
For, I'm sorry, our marginal rate of substitution of pizza slices for movie tickets.
It's going to be low.
It's going to be low. So, let me erase this here. Marginal rate of substitution for X is low when our indifference curve what's the slope of the indifference curve looking like? It's very flat. It's flat. And basically the marginal utility of our x-axis good the marginal utility is low. And the marginal utility of the y-axis good is high. Why is it high? Because we don't have very many of them. Diminishing marginal utility. Okay, so then in general, we'd say that because our ratio, remember we still have the marginal utility of x over the marginal utility of y, at that point, our marginal rate of substitution is going to be pretty low. Yeah, so basically we think, sorry, the x's and y's are low. Try to be careful with that. So if this is really low, you can kind of think of it as decreasing as you're going up, as you're getting more. As you're going along this curve, you're going to see the marginal utility of x is going to go down, while the marginal utility of y is going to go up. And we see that connection with the slope of the indifference curve. And that's what the marginal rate of substitution is measuring. Okay, so that makes pretty. Does that make sense? Do you guys have any questions on that? Okay, we're just trading off goods, keeping the same level of utility. Okay, so now that we understand the marginal rate of substitution pretty well, let's introduce another concept that is a little bit more concrete units. Because right now we're talking about marginal utility, we're measuring utils. Well, what about our dollars and cents? Like that's really how we kind of determine things in the market. When you go to the store, you don't think, I mean, actually, if I'm doing my job well, you guys might start thinking about what's my marginal utility of buying another t-shirt today? When I already have 20 t-shirts at home. But let's think about these trade-offs in terms of prices. So, if we were super, super rich, we might not have to worry too much about our budget line. Maybe we could always get D no matter what. We would be limited only by our imaginations. But for the most part in life, you're limited by your budget. So we're going to introduce the concept of a budget constraint to help us visualize this idea that we can't buy everything we want all the time. Sometimes we're limited by our budget. So let's talk about, we call it our budget line or budget constraint. And this is going to show us how much we can buy depending on our prices. So first of all, we've already got our axes labeled. We want to make sure that we have our units. We've got tickets, slices, pretty simple units. Now, let's imagine that, here's our example. Let's say that the price of movie tickets is going to be $6 per ticket. The price of pizza slices is going to be $2 a slice. And let's say that our income is $18. Now you can always think about, whenever you're talking about your income, there's always like a time frame here. We're talking about maybe this is a week. This is like your extra spending money after you pay your bills or whatever. Or maybe this is just your budget for pizza slices and movie tickets. However you want to think about it, the income is your limitation, and then the price determines how many you can get of each thing. So as we're drawing this, so we've already drawn our axes, and we've labeled our units. Now, if we spent, how do we think about our y-intercept? How would we find our y-intercept? Yeah, how many pieces of pizza could you buy if you only bought pizza, right? So how would